Cumulative distribution function. The cumulative distribution function, or CDF, tells us the total probability up to a given value. Let's consider a simple rectangular distribution such as the one below. We can see that it's non-zero between 2 and 8, which is a width of 6. So since we need this area to be 1, the height of the rectangle is 1/6. This will be 0 everywhere else. So remember, this is a graph of the PDF, or probability density function. Clearly, the probability that x is less than or equal to 2 is 0. Now consider the following. Let's suppose we go up to 3. The probability for 3 or less is going to be the area of this rectangle. So the probability that x is less than or equal to 3 is going to be 3 take away 2, that's the width of the rectangle, times the height, 1/6, which gives us 1/6. Now consider this rectangle. Should be clear that the probability is going to be 2/6 or 1/3. And if we go as far as some general value x, which is between 2 and 8, then the probability that x is less than or equal to x is going to be x take away 2 times 1/6, which we could write as 1/6 x minus 2. So, the probability that x is less than or equal to x is equal to 0 for values of x up to and including 2. And that's because the probability density is 0 in this region down here. So there's no area when we're down here. But it's going to be 1/6 of x take away 2 for values of x that are between 2 and 8. Once we reach 8, the cumulative probability is 1, because that would be 8 minus 2, which is 6, times 1/6, which is 1. Then, as soon as we're past 8, the probability that x is less than or equal to x is always going to be 1, because once we reach 8, it's 1. So therefore, the probability that x is less than or equal to 9 or 10 or 100 is 1. For this distribution, the probability density function is 1/6 for values of x between 2 and 8, and 0 otherwise, which we can see on the diagram. The CDF is 0 for values of x below 2, 1/6 of x minus 2 for values of x between 2 and 8, and 1 for any value of x greater than 8. Now let's consider a more general case, such as this. The area shown in the diagram will be the integral from a to c of p of x dx. And this would represent the probability that x takes a value between a and c. But more importantly, when we're talking about the CDF, it represents the probability that x takes a value of c or less. If we wanted the area between a and d, we could calculate this, which would be the probability that x takes a value of d or less. Remember, with cumulative probability, we're talking about the amount of probability up to a given point, or from this point backwards. For a general value x between a and b, the probability that x, and the capital X here represents our random variable, takes a value less than or equal to x, remember, or equal to in brackets, because the probability of actually taking the value x is 0, is given by the integral from a to x of p of x dx. So if we have some value in here, x, and remember that could be any value between a and b, the probability that our random variable x takes a value less than or equal to x is given by this integral here. The cumulative function then can be stated as 0 if x is less than a. Because there's no probability density down here, we can't calculate any areas. Between a and x, it will be the integral from a to x of p of t dt. And I'm just using the t here so that I don't use x both as a limit and as the integration variable. By the time we get to b, when x is equal to b, that area should be 1 if this is a valid probability density function. And that means that our cumulative probability is 1 for any value x, which is greater than or equal to b. And remember, it doesn't matter whether I say just greater than here or greater than or equal to, because the probability of actually being equal to b is 0. Remember that the CDF is defined as f of x is equal to the probability of x being less than or equal to x. So if, for example, we were asked to calculate the probability that x is between 3 and 5 for a particular distribution, and we had the CDF, we could calculate f of 5 take away f of 3. This is because f of 5 is this area. F of 3 is this area. And the area we want is this area just here, which is the first area. Take away the second.